Namaskar. So, today we will discuss about the topology. What do you mean by topology? As we know that the network is not as a series circuit or as a parallel circuit. Till now we have analyzed the series connected circuit or parallel connected circuit. But actually in real scenario this electrical circuit will not be a series or parallel, it will be a combination of both. So, the objective of the electrical circuit analysis is that you need to find out the currents and the voltages across element which is connected to the network. So, what we will do, we will try to analyze the circuit and try to find out the currents which are there in the various branches of the network and the voltage across the components. Let us recap what we discussed till now related to circuit analysis. There are various laws which are used to determine the currents and voltage drops in the electrical circuit. We discussed about the Kirchhoff's law, we also discussed Ohm's law. Ohm's law is nothing but the finding out current I, that is V by Z. Now, here we are using Z instead of R because Z is the complex impedance and is generally visible when you have the AC sinusoidal waveform in the circuit and then the voltage across the impedance. Now, law of impedances in series and parallel are like when you want to find out the total impedance in a series connected, it will be summation of all the impedances connected in series, or if you have the parallel connected, then better to convert impedance into admittance. Admittance is nothing but Y and it is reciprocal of the impedance Z, and then you can sum up to find out the admittance. Now, let us look at impedance and admittance in detail, so that you can understand the concepts of these two entities with relations to the AC circuit. Now, voltage current relation which we have discussed till now was something like this. We had V, that is phasor value, is nothing but R into I phasor. For this was for the case of resistor. For inductor we discussed V was j omega L into I phasor, and for capacitor the relationship was the voltage phasor V is nothing but I phasor divided by j omega C. Now, if you write the equation in terms of ratio of phasor voltage and phasor current, you can simply write V by I is equal to R, or V by I is equal to j omega L, or V by I is equal to 1 upon j omega C. So, now if you are asked to find to represent all the three equation in a generic term, what we write? We write V by I is nothing but equal to Z, and this follows the Ohm's law, or alternatively V is nothing but Z into I. Now, here Z is a quantity which is called impedance. What are the various properties of this impedance? The impedance of a circuit is the ratio of voltage phasor and current phasor, and it is also measured in ohms, because in case of resistor or capacitor or inductor, whatever the reactances which we calculated in previous lectures, the dimension of those was in ohms. Now, impedance represents the opposition that circuit exhibits to the flow of sinusoidal current. So, whenever the impedance term comes into the picture, it means that the circuit is AC circuit and the current is sinusoidal current. Now, although the impedance is the ratio of two phasor, that is phasor V divided by phasor I, but it is not a phasor because it does not have the sinusoidal varying quantity. The complex quantity for impedance is generally represented as Z is equal to R plus Jx, where R is the real term and this real term is nothing but the resistance in the impedance term, and then x which is imaginary part of z, and this imaginary part is called reactance. Now, impedance is inductive when x is positive. So, here if you are writing z is equal to r plus jx, if this is the positive quantity, it means that the impedance is inductive, while it would be capacitive when x is negative. So, in that case your inductance would be capacitive, the impedance would be capacitive impedance. Now, impedance is z is equal to r plus jx. So, it would be inductive when it is lagging, since the current lags the voltage. When z is equal to r minus jx, it is capacitive because the current leads the voltage. If we have to represent the complex quantity z in the polar form, we write simply as z is equal to mod of z, that is the magnitude of the impedance z, and angle theta. So, in summary you can say that z can be represented as r plus jx, or in polar form mod of z, that is magnitude of the impedance z, and angle theta. These two you can use interchangeably based on the requirement in the calculation, and you can calculate mod of z using rectangular the equation of z, that is mod of z is nothing but under root of r square plus x square, where angle theta is tan inverse x by r. Or if you want to convert polar into rectangular, you can say r is nothing but mod of z cos theta and x is mod of z sin theta. Now, sometimes it is convenient to use reciprocal of impedances in calculation. This happens specifically when you have parallel connected circuits, like if you have impedance connected in parallel like this. So, if it is Z1, Z2, Z3, the equivalent impedance, if you have to find out, it is better to take the reciprocal of impedances. So, if reciprocal of Z1 is Y1, is Z2's reciprocal is Y2, and similarly for Z3 reciprocal is Y3. So, you can easily say that the equivalent admittance Y is equal to Y1 plus Y2 plus Y3, and if you have to find out the impedance, then the equivalent impedance Z would be 1 by Y. So, in this case, when you have parallel connected networks, it is better to convert impedance into admittance. Now, admittance is nothing but reciprocal of impedance, and it is measured in Siemens, or you can say it is also measured in mho. So, mho and Siemens both are same, you can use them interchangeably, and the admittance is expressed mathematically as y is equal to 1 by z, or you can write I by V. Now, similar to impedance, if you are asked to represent y in terms of rectangular coordinates in complex z plane, you will write G plus JB, where G is called conductance and B, which is imaginary part of y, is called susceptance. So, what is G plus JB? G plus JB is nothing but 1 upon Z, and Z is nothing but R plus Jx. So, if you simplify, you will get G plus JB is nothing but R minus Jx divided by R square plus X square. So, if you compare real and imaginary terms from both of the components, you can simply say G is nothing but R upon R square plus X square, and B is nothing but minus of X upon R square plus X square. So, this admittance you can use whenever there is a requirement to analyze the circuit, which is like this in this case. Now, let us talk about the network. Till now we have discussed, like every time we use electrical circuit, not the network. So, what is the difference between network and circuit? The difference between a network and circuit is that the network is an interconnection of elements or devices. That means that it is not necessary that it will create a closed loop. So, it can have the closed loops, but there may be some open loops also. So, network is the broader term for the circuits, while in case of circuit it is network which providing one or more closed paths. So, the difference between network and circuit is that network is generally regarded as a more generic term for the electrical circuit, where the circuit can be opened or closed, while in case of electrical circuit we make sure that there is a written path for current to flow. So, in electrical engineering we generally use both of them interchangeably, because a network is more generic terms. So, we in this particular course also we will use sometimes network, sometimes circuit, but that means the same thing. Now, let us talk about the topology. So, for network topology, what is the topology? The properties which is relating to the placement of elements in the network and the geometric configuration of the network. So, what does it mean? Generally when you see a particular network, like if you represent here, there is a resistor. If you take the circuit like this, so suppose all are of equal resistance R and this is voltage V. So, if this is the circuit, you may be interested to find out the connectivity information. So, connectivity information means you need to find out how the various elements are connected. Now, if you give this node as A, this node as B, this node as C, and this is O, that is the ground or maybe origin you can say. Now, if you are asked to find out the topology of this circuit, what you will do? You have to simply construct the graph which will replace all the elements of the network with lines. Why? Because the graph what we are creating is describing the topological properties of the network. So, from the circuit, if you create a graph which describes the topological properties, that means the connectivity information of all the elements in a particular network, then that particular network will be the topology of that particular circuit. So, here if you see A is connected to C, so instead of adding R, we are simply adding the line. A is connected to C, then between A B resistor R, so we are again creating a line. B to C, we are connecting the line. C to O, that is again we have one line. So, for this R it is the line. For B to O, we are again creating the line, and between A to O, because this is the voltage source, we are again creating the line. So, this particular circuit will be equally represented as a graph in this fashion, which will remove all the elements. There may be the sources, that may be the voltage or current sources, or the resistive, capacitive or inductive elements in the circuit. So, what we get is called the graph of the circuit or graph of the network. So, this is very important because we have various topological properties associated with it, which will help us to analyze the circuit. Now, what we got is the skeleton of the network. Here the elements which you will see would be like nodes, we will see the loops or we will see the branches. Now, if you add the reference direction by an arrow for each of the lines of the graph, then it is called a oriented graph. That means that you, when you analyze the circuit, you imagine the initial direction of maybe the current. So, then if you show the direction of the current, then this will become a oriented graph. Now, lines in the graph are called branches and junction will be called as node. Now, why the topological information of the network is important? Because the topology shows us the property of the network which is unaffected when we stretch, twist or distort the size and shape of the network. That means that if you have the network and you change the orientation of the graph by stretching, twisting or distorting its size, if you keep the connectivity information intact, all the different types of stretches or distort you have created with that particular circuit will always remain same, because the topology of the network is same. Say in this example, if you see the topology of one particular circuit is like this, where A, C, B, D and A, B are connected in this fashion, and there is another circuit where you create the topology in this fashion, where these elements are connected like this, and third one where the circuits are connected in a triangular fashion. Now, if you see all these three from first look, it looks like that all three are different, but eventually all the three circuits are same. Why? Because the connectivity information in all the three topologies are same. Say in this example, if A is connected to C here, A is connected to C here and A is connected to C here. A is connected to D, A is connected to D and A is connected to D. C is connected to B, here C is connected to B and here also C is connected to B. B is connected to D here, B is connected to D here and B is connected to D here. Now, C is connected to D in this fashion, here C is connected to D in this fashion and here C is connected to D in this fashion. Finally, we are connecting A with to B through straight line, here we are connecting A to B like this and similarly A is connected to B like this. Now, since connectivity information is same, it means that topology is same. Why it is important? Because sometimes in the circuit, if it is given the figure is given in a different way, you can better convert it into a similar type of circuit where it is very easy for you to analyze the current flow and the voltage drop across the element. So, that is why the topology information is very important, where you can understand the topology configuration of the circuit and you can stretch, twist or distort that particular circuit in such a way that it is easier for you to analyze. So, although the three graphs which we discuss are different, but they are actually the identical topologies. Why? Because relationship between branches and nodes is identical in this case. Sometimes the topological structure in the electrical circuit occurs so frequently that in electrical engineering we have given them some special names. Like if you see circuit like this, we call them as T network. If it is like this, where you may have resistor connected like this, then it is called a pi network. If the circuit topology is like this, it is called a ladder network. When the topology is like this, where two resistances are connected parallelly with one resistor, and in between you have another resistor, or maybe you can say all of them are impedances, then it is called bridge T network. Similarly, if it is connected in bridge fashion like this, it is called bridge network, and this is called the lattice network. So, these are the most common topologies you will encounter in the electrical circuits. So, if you can understand the topological information, it is very easy for you to analyze the circuit. Now, let us talk about the subgraph. Subgraph of a given graph is formed by removing branches from the original graph. So, if you remove one branch like this, if you remove, it will become a subgraph of the original graph. Now, what is tree? Tree is one kind of subgraph which is important for our circuit analysis, and it is formed by removing a branch from the graph. So, tree can also be considered as a subgraph, but it has some special properties. What are those properties? Tree of n nodes, suppose if there are n nodes in a particular graph, and we are creating tree containing all the n nodes, then it will have the following property. It will contain all nodes of the graph, it will contain n minus 1 branches, and there will be no closed path. So, these are the three major properties of tree, and let us understand this property from this figure. If you are asked to find out the tree, then first is that it will contain all nodes. It means that node A, B, C and O should be part of the graph. It will contain n minus 1 branches. So, we have 1, 2, 3, 4 nodes. It means that it will have n minus 1, that is 3 branches. What would be 3 branches? The 3 branches can be this, because it makes sure that there is no closed path. Or alternatively, what you can do? You can have the nodes, but your branches can be 1, that is second, and it can be third. In this case also, you know that all the nodes have been traced, but there is no closed loop. Or similarly, you can do one more thing, that you can connect through some other fashion like this, and that again a tree. So, there may be many possible different trees of a graph, but if you connect it through some other fashion, like if you connect from O to C, C to B and B to A, then you will again find the tree. In all the cases, if you see, there would be precisely 3 branches, because it will contain n minus 1 branches. So, for 4 nodes, it will always have 3 branches. If you connect more, then definitely you will have one closed loop, which is not allowed in this case. So, tree will have precisely no closed path. Now, the branch graph in forming a tree are called chords or the link. So, if you remove this particular branch, then you get one tree. So, this is called chord. The concept of tree is used where we have to carry out the proper choice of current variables for the analysis of the network. So, this is very important when you have to choose the current variables for circuit analysis properly. Now, let us talk about the elements which we just saw in the network topology. One is branch. Branch represents a single element such as voltage source or a resistor. So, in this case, this can be considered as a branch, this can be considered as a branch, this can be considered as a branch, this can also be considered as branch, and this can also be considered as branch. So, basically wherever we see the electrical elements present, that particular segment is called a branch. Now, let us talk about node. Node is the point of connection between two or more branches. Now, in this case, this is the node because it is connecting this and this branch. So, node will be the connection between two or more branches. Here in this figure we have 3 nodes, node A, node B and node C. Now, in this figure C is not a single node, it contains all 4 nodes which are there in the circuit, but we represent it by a single node C. Why? Connect 2 nodes with a short circuit or maybe the direct wire, both will always be at a same potential. So, when it is like this, you can join all of them and create one single node. So, eventually if you have 4 different nodes, is nothing but you are talking about one single node, because you can join them without any change in the circuit configuration. Similarly, in this also, although you have a 3 nodes, but since all are connected through direct wire, means all 3 nodes are short circuited, then you can equivalently represent all the 3 nodes with one single node. So, here you will have in B you will have 3 nodes, but actually it is considered as one node. Similarly, for this also you have 4 nodes, but it is considered as single node because of the wires which are connecting these nodes are not having any elements, and it can be considered as a short circuit node. Now, what is loop in any closed path? Loop is basically a closed path in any circuit. The closed path formed by starting at a node, passing through set of nodes and finally returning to the starting node without passing through any node more than once. So, that means if you see the circuit like this, when you are asked to find out the loop, it means that if you trace out various nodes and come back to the original node, then this will consider to be one loop, right. Now, this particular loop is said to be independent if contains at least one branch which is not part of any other independent loop. Now, why the loop is important? Because independent loops or paths result in independent set of equations. So, when you have given a complex circuit and you are asked to execute the Kirchhoff voltage law, then you have to first find out what are the various independent loops, so that you can precisely identify what are the various equations or unique equations you have to find out, so that you can find out you can get the answer of that particular circuit. Now, if you see this figure, if you connect A, B, C and A in this fashion, A, B, C and A, this will be considered one independent loop, or alternatively you can go with A, B and C, which is through 2 ohm, and then A, that will be another independent loop, or you can have 2 and 3 ohm connected, that is also another independent loop. So, in all the 3 cases you will see that at least one element in the loop is not part of other loop. So, in that way you can create the number of loops. Now, the question would be how you will find out whether you have got the correct number of loops or not. For that we use the fundamental theorem of network So, V is nothing but L plus n minus 1 number of loops, n is number of nodes and B is number of branches. So, you know you can find out the number of nodes, you can find out number of branches. So, you can easily find out what would be the number of loops. So, L would be nothing but B minus n plus 1. So, you can count number of loops which you have created and try to find out whether number of loops are satisfying this particular theorem or not. If it is satisfying, it means that you have precisely identified the number of loops in the circuit. Now, there are two or more elements which are in series, they exclusively share a single node, and then you can say that those will carry the same current. So, that we have also already seen in the series and parallel circuit analysis that if the elements are connected in series, means they will share a single node and they will carry the same amount of current. Now, if there are two or more elements which are connected in parallel, then they are connected to same two nodes and consequently have the same voltage across them. So, it means that if the nodes are connected in series, then they both elements will be connected through one single node. So, in that case you have the same current flowing in the both of the elements. Now, if those are connected in parallel, then these elements would be connected through the same two nodes, and in that case the voltage across both of the resistors will be same. So, this will give you an idea that if you have node configuration like this, it means that the current will be same if they are connected in this fashion and voltage will be same if they are connected in this fashion. So, with this we close today's session. In next session we will try to analyze some other circuits which are like circuit combination of series and parallel, and how to make them easier to understand and how to analyze, so that it is very easy for us to find the solution of those circuits. Thank you.